the lecture of inverse Laplace transformation. So today we'll do the inverse Laplace transformation. That is what we call inverse Laplace transformation. Now let us understand the concept. Inverse Laplace transform. First of all, the basics of that. Now we have defined it is like that if L of ft is say f of s, then we define L inverse of fs as ft. It means that the Laplace transformation of the function is given to us and we have to find the Laplace transformation of the function is given to us if it is fs. So now the next question is, if the inverse transformation is given to us, then we have to find the corresponding function. That is what we call the inverse Laplace transformation. Now some formula that we had done already, that Laplace of 1 we defined as 1 by s. So which is applicable, that is if and only if L inverse of 1 by s is 1. And this is the first case. Second case that we had done as Laplace of 1 upon s minus a is e to the power at. Oh, sorry, we have written a little bit in the wrong sense. That is Laplace of e to the power at as 1 upon s minus a. If and only if L inverse of 1 upon s minus a is e to the power at. Similarly, we had done that the inverse transformation of e to the power minus at as 1 upon s plus a. So if and only if L inverse of 1 upon s plus a is e to the power minus at. So therefore, now we have to apply the formula from this direction to this direction, that is from here to here, here to here. So now I am going to convert some more formulas in the form of inverse transformation, and then we will do their application. Let us consider this situation also. That is, we had done that the L of t to the power n as that, what was the formula of that? That is gamma of n plus 1 upon s to the power n plus 1. So now I can say that inverse transformation of 1 upon s to the power n plus 1 is t to the power n upon gamma n plus 1. Another thing that we had done, that the Laplace of sine at was a upon a square plus s square. So I can write that the inverse transformation of 1 upon a square plus s square is sine at by a. Similarly, we had done that the Laplace of cos at as s upon s square plus a square if and only if inverse transformation of s upon s square plus a square as cos at. That we had already done. Okay. Another thing that we had done, that the Laplace of cos hyperbolic at was s upon s square minus a square. So if and only if that is the inverse of s upon s square minus a square is, it will be simply cos hyperbolic at. And we had also done that the Laplace of sine hyperbolic at as a upon s square minus a square. So if and only if that is the inverse transformation of 1 upon s square minus a square is simply sine hyperbolic at by a. So this way we can convert the normal formulas of the inverse transformation in the format of inverse transformation. So without loss of generality, now we'll do some application of this. Now let us start to do some application part of these formulas. Now suppose my question is, some basic applications. Some basic applications. Some basic application. That is, if I ask you what is the inverse transformation of 1 upon s square plus 4, so I can write this as L inverse of upon s square plus 2 square, which is same as sine 2t by 2. Okay, so we can write in this particular format. Okay, if somebody asks you what is the inverse transformation of, that is 1 upon s square minus 3s plus 2. So I don't know the exact rule. So what can I do? I can factorize this as 1 upon s minus 1 into s minus 2. It is like that. And then we can write their partial fraction as a upon s minus 1 plus b upon s minus 2. Where a and b will be constant, so that can be brought outside the inverse transformation sign. It is 1 upon s minus 1 plus b of L inverse of 1 upon s minus 2. It is a into e to the power t now plus b into e to the power 2t. Now find the value of a and b if you are using partial fraction, so you will get the inverse transformation of this also. Now the same argument we are moving ahead. Okay, now one more application of this. Suppose I have to find the inverse transformation of, see, this is also an important result, that is what we call 1 upon s to the power 4 minus a to the power 4. So now, can I write this as L inverse of 1 upon s square plus a square into s square minus a square? This can be further written as L inverse of 1 upon s minus a s plus a into s square plus a square. It is like that. So in terms of partial fraction, it will be a upon s minus a plus b upon s plus a plus c s plus d upon s square plus a square. It is like that. And please note that in the inverse Laplace transformation, we can plot out this constant outside the inverse transformation. So it will be simply a into L inverse of 1 upon s minus a plus b times of L inverse of 1 upon s plus a plus c times of L inverse of s upon s square plus a square plus some d times of L inverse of 1 upon square plus a square. Now see that all these formulas are well known to us. So I can write this as a into e to the power at plus b into e to the power minus at plus c into cos 2t plus cos, in fact not 2t, that is cos 80 and then plus d into sin 80 by a. Now please find the value of a, b, c, d. Find a, b, c, d by using partial fraction. By using partial fraction. So this way we can simplify this type of problems also. So I think it seems to us that it is a very simple process to find the inverse transformation. Okay. Now, so it means that we can find the inverse transformation by using partial fraction also, if we have a rational function. Now, let us see that what will be the impact of the first shifting theorem in the inverse transformation. That we did this first shifting theorem as first shifting theorem was that if L of ft is say fs, then L of e to the power at into ft was f of s minus A. Now, in inverse transformation, we will write this as, if L inverse of Fs is say f of t, then L inverse of f of s minus a is simply e to the power at into ft. Okay, it's a very interesting thing that the inverse transformation of the function is known to us. Then if we have to find the inverse transformation of function of s minus a, then it is of that format. Suppose the question is, find the inverse transformation of, say, 1 upon s square minus 3s, in fact minus say 2s plus 3. Now can I write this as L inverse of on, that is s minus 1 whole square, and then plus root 2 whole square. So if I take my function of s minus 1 as upon s minus 1 whole square plus root 2 square. So now according to that here my a is equal to 1. So therefore inverse transformation of f of s minus 1 simply e to the power t into L inverse of f of s. Now understand that what is f of s. Here I have written function of s minus 1. So corresponding to this, if I take f of alpha, can I write this as alpha square plus root 2 square, where alpha is s minus 1. So similarly, I can write this as f of s as 1 upon s square plus root 2 square. So therefore it is nothing but e to the power t L inverse of 1 upon s square plus root 2 square. So which is nothing but e to the power t sine under root of 2t by root 2. That is the answer. So therefore, so the inverse transformation of this function is nothing but, you write this as e to the power t into sine under root of 2t by root 2. That is my final answer. So I think it is a very interesting thing that if you know the inverse transformation of this function, and if they ask you that is what is the inverse transformation of the function of s minus a, then you keep it like that. Okay, by same argument we can write this as that L inverse of f of s plus a is simply e to the power minus at into ft. This is the second version of the first shifting theorem. Okay. Now we are moving ahead and we will do some more problem on first shifting theorem. Now let us understand this concept also. Okay, I am removing this for timing. Suppose my question is what is the inverse transformation of 1 upon s minus a whole to the power n. Now here I am having f of s minus a as whole to the power n. Okay, by first shifting theorem, L inverse of f of s minus a is simply e to the power at into ft. Now what is ft? That is L inverse of f of s. Okay, now we will try to resolve this situation. So therefore L inverse of 1 upon s minus a whole to the power n is simply e to the power at into L inverse of 1 upon s to the power n. Why it is so? Please note that the function of s minus a is 1 upon s minus a whole to the power n. So simply corresponding to this f of s, simply s minus in fact s to the power n. Here I have taken only s minus a as a variable, so that is why it is appearing like that, 1 upon s minus a whole to the power n. Here I have taken, instead of s minus a as a variable, I am keeping s as a complete variable, so therefore it is 1 upon s to the power n. So we have already studied that the inverse transformation of 1 upon s to the power n plus 1 was equal to gamma of, that is what we call t to the power n upon gamma n plus 1. It is like that. Okay, now here we have s to the power n, so it will be e to the power at into t to the power n minus 1 upon gamma n plus 1. So this will be the formula. So now instant application of this formula is, somebody asks you what is the inverse transformation of 1 upon s minus 2 all to the power 5. Now apply this formula. Apply this formula. It will be simply, now what is my a? A is 2, e to the power 2t. Now what is my n? N is 5, so I can write this as t to the power 4. And by, what is my n here? Here my n is 5, so it will be simply gamma 6. That is e to the power 2t, t to the power 4 by 5 factorial. So it is like that. Okay. Now again we will move ahead. So this is all about the application of first shifting theorem. Now we'll move ahead. So we'll do lot more application of the results. Now I'm removing this for timing. So now let us understand the another important application. We did the rule, that is multiplication by t to the power n. By t to the power n. What this rule is suggesting to us, that is to say that if L of ft is say f of s, then L of t to the power n into ft is simply minus 1 to the power n dn by dsn of f of s. This thing we had done. Okay, and please note that here n is a positive integer. N is a positive integer. Okay, if it is the case, now in inverse, how we'll write it? In inverse, transform, that is, if L inverse of f of s, say ft, we know the inverse transform of the function, and the question is then the inverse transformation of nth derivative of the function f of s will be simply minus 1 to the power n into t to the power n into ft. So it means that if you want to find the inverse transform of the nth derivative of the function, so what you have to do, that the inverse transformation of the function that you have already known, you multiply it by t to the power n times of minus 1 to the power n. Okay, now we'll do the application based on this result also. It is a very good trick to find the inverse transformation of the certain function whose inverse transformation we cannot determine directly. We cannot determine directly. Now let us consider this situation also. The question is, what is the inverse transformation of tan inverse of what we used to call, that is a by s. Suppose I have to find the inverse transformations. I don't know the right hand side of, so what I am assuming, let L inverse of tan inverse of a by s as simply f of t. So then L inverse of d by ds of tan inverse of a by s is simply minus t into ft by multiplication t to the power n. Because the rule was, that is L inverse of dn by dsn of fs as minus 1 to the power n t to the power n into ft. Now n is 1. Now let us differentiate it. Now what I will get after differentiation? 1 upon 1 plus a by s whole square into minus a by s square as minus t into f of t. Now if we simplify it, what I will get? This s square will get cancelled with this. That is minus a upon s square plus a square is minus t into ft, which is this will imply that is minus sine at is equal to minus t into ft. So now our ultimate aim is, this will imply ft is sine at by t. So that's what I want to determine. So my ft is nothing but sine at by t. So this way we can find the inverse transform of the function of this type also. Now again we are moving ahead. Now I will do one more example based on this concept. So this concept seems to us as a very interesting concept. Suppose if we don't know the inverse transformation of some of the functions directly, so then we can apply this rule. Now let us think over this example also. We want to do the one interesting example, that is what we call, suppose I have to find the inverse transformation of log of s plus a upon s plus b. As usual, I don't know what will be the right hand side. So what I am assuming, let L inverse of log of s plus a upon s plus b as f of t. Again, I don't have any direct formula, so this will imply L inverse of d by ds of log of s plus a upon s plus b simply minus t into ft. I can write this way. That this will imply, that is L inverse of, what will be the differentiation of this, s plus b upon s plus a. Now applying the quotient rule, what I will get? S plus b minus s plus a upon s plus b whole square as minus t into ft. So this will get cancelled with this. Now this will get cancelled with this. So b minus a outside the inverse transformation. So it will be simply 1 upon s plus a into s plus b, which is equal to minus t into ft. Now I think for this we can easily get its inverse transformation. How we can get this inverse transformation? We can get this inverse transformation simply reducing this expression into its partial fraction, and then we can get the inverse transformation of this function also. So now let us find the inverse transformation of this function also. So therefore, in order to get this, I am removing the first two lines of this question. So therefore, from this point, I can write this as b minus a of L inverse of, I can say that a upon s plus a plus b upon s plus b as minus t into ft. Now, please note that, can I write this as b minus a L inverse of, please try to understand the rule of partial fraction. So I can easily write this as 1 upon s plus a minus 1 upon s plus b upon 1 upon b minus a of minus t into ft. Now see that this b minus a will get cancelled with this. So therefore, now again let us move ahead. So this can be further written like that. So this will imply L inverse of 1 upon s plus a minus L inverse of 1 upon S plus B is simply minus G into Ft. Now what about this? It is e to the power minus At minus e to the power minus Bt is equal to minus G into Ft. So this will imply my Ft will be equal to e to the power minus Bt minus e to the power minus At by t. So that's our aim to determine. So we have finally determined the inverse transformation of that particular function. Okay, now again let us move ahead. Okay, now I will do second shifting theorem and its application into the inverse transformation. Second shifting theorem. What this theorem is saying that if L of Ft is say Fs, then L inverse of say then L of f of t minus a into u of t minus a, where it is a unit step function, it is e to the power minus sa into fs. It is a very interesting result. In inverse transformation, in inverse LT, that is inverse Laplace transformation, that is if L inverse of fs is known to us, say it is f of t, then L inverse of e to the power minus sa into fs simply f of t minus a into u of t minus a. It is like that. So now it means that if you want to find the inverse transformation of one of the exponential function and the function fs whose inverse transformation is known to us, then it will be simply f of t minus a into u of t minus a. So now I am going to apply this result to find the inverse transformation of certain function. So now let us understand the concept. Suppose I have to find the inverse transformation of e to the power minus 10 times of s upon s square plus 1. This is my question. So now if I compare this with s, L inverse of e to the power minus sa into fs by second shifting theorem was u of t minus a into f of t minus a, where f of t is the inverse transformation of fs. So if I compare with this here, a is 10 and fs is 1 upon s square plus 1, and the inverse transformation of fs is simply sine t. Okay, so this is my f of t. So therefore L inverse of e to the power minus 10s upon s square plus 1 simply, what it will be? U of t minus 10 into f of t minus 10. Now what will be f of t minus 10? Because ft is sine t. So it will be u of t minus 10 into sine of t minus 10. That will be the answer. So now I want you to do one more example also of this type. So it is a very interesting result. So it is